Can I hear me? Ah, great. Morning, everybody. Yeah, I have to be fast. You see, it's 107 slides to go. We're a bit late, and my English isn't that good. So, wish me good luck. Yeah, hi, everybody. Nope, won't work. Worked 2 seconds ago. Okay, so I'll do it that way. Hey, obviously everybody already left, so we can just start. I already see some known faces. That's great as well. A lot of people from the German PHP community as well. Who's from Germany? Surprise, surprise. Who's not from Germany? Okay, so I have to stay with English. Bad luck. Yeah. A lot of better looking people than on the average PHP conference. That's great, that's why I do conferences like this. Good morning, and yes, I'm tired too. It's too early for a conference talk. In my opinion, it is. I've already had like 4 coffees, so. But let's start. Since we are in Germany, that's the country where the Brothers Grimm are from, I'm going to start with a short story, or better, with 2 short stories. And since we are in Berlin, and I think Berlin is really, really good at starting a war, so I'm going to tell you war stories. The first war we survived, this is already some years ago, like 5 years. Gaylord Alke isn't here yet. He was involved as well, so he can tell you about it as well. It was a big on-demand video streaming platform, and it was the first one that was able to stream live events in Germany. And those live events were big live events, so they were important and everybody wanted to see it. So it had to be reliable and it had to be successful, because there would be a lot of money money being lost if it won't work. So the solution was based on an enterprise e-commerce solution. I won't tell any names. Today, every e-commerce solution is some way of enterprise anyway. And so it should scale. It's enterprise. It's able to scale. It won't be enterprise otherwise. The other reason why it should work was that we are involved, or we were involved, and we are professionals. At least that's what we tell our customers. So we were involved to provide scalability and performance and so on. So we thought, okay, let's do this right and make a proper server setup. So we installed the whole solution based on this e-commerce solution on one server, benchmarked it, and figured out how many CPU cycles we might use, what the bottlenecks are going to be, how much database server we need, how much memory we need, and so on. And we calculated, okay, we need 12 servers to get everything up and running with 4 cores each. That was high-end at that time. So we did a proper, still does not work, server setup. And we thought, oh, everything's great. But server setup isn't the whole thing you have to provide. You have to do some performance testing as well. And we thought, let's do it right. So we did the same thing everybody else does in that cases. We used Apache Bench and generated a lot of traffic, and everything looked good on this cluster. Load balance on the front, 12 servers on the back end, 3 database servers have been involved as well. And because AB, or Apache Bench, isn't everything, we did some JMeter testing as well. And we did user simulation and everything you have to do to have a proper JMeter test. And we thought, oh, everything's great. Yeah? We figured everything out, we did proper testing. For launch, I'm going to be in some other country because there's no need for me here. Yeah? Because everything is going to be stable. And it was everything stable until 10 minutes before the first live event happening on this platform. Then everything was stuck and did not work anymore. Bad luck. So we did proper profiling, we did proper benchmarking, and we did proper fail. Second war story, not so long ago. We did a cloud project. As you already hear by the name cloud, this was 100% hipster. 100% hipster means Memcache, RabbitMQ, eJabberD, Varnish, Nginx, ModuleFS, private and public cloud involved as well. Everything's in there. Of course, there was a deployment pipeline, Puppet manifest to maintain the whole infrastructure and so on. And so this was developed on a state-of-the-art level, highly professional. We did the development on the internal clouds. The performance was nice. It's a cluster software. It's like 5 or 6 servers. And the responsivity was quite snappy. It was fast. It was very nice. So we thought everything's fine. It works fine in our staging environment on the Eucalyptus cloud. Who does Eucalyptus cloud in here? Nobody. OpenStack? Ha! OpenNebula? It doesn't matter because it's a pain in the ass anyway. So if you do it, you hate it. We hate it too. And we did like everything, like OpenNebula as well as OpenStack and any other cloud solution. So we thought this works fine, so let's put this into production. And in production, what happened? It was very, very, very slow. And we thought, can't happen, can't be. Our customer wasn't that happy because every time we demonstrated the platform running in our private cloud, he saw that it was snappy, it was fast. And in production, it wasn't anymore. It was like 2 seconds for the start page, 1 second for every logged-in page, and then it was some kind of social network site. Every page was a logged-in user page. So there was pretty much no page being delivered faster than 1 second. So pretty slow. So we did what everybody else does in that cases. We did some performance optimization. We implemented ORM-level caching doctrine in this setup. We implemented APC with memory caching. We did memcache-based memory caching. We did object caching, template caching, like every caching you can just possibly implement on this platform. But nevertheless, it was still very, very slow. So we had this large cluster on Amazon EC2. There were like 6 large instances. Large instances have a good CPU power, a good memory usage, like 8 GB or so. And it was very, very slow, and we just couldn't understand it. So we gave it a try. We had a look in our old computer storage and took a pretty old laptop, a Lenovo R61. Who's got a Lenovo laptop? Most of the time they're like, you go Apple or you go Lenovo. There's no way around it if you're a software developer. And that was a Lenovo R61, so it's a Core Duo processor inside. That's not that fast. It's got 4 GB of RAM, so it's not that much RAM as well. And surprise, surprise, it was like 5 to 10 times faster than the Amazon cloud. Yeah, enterprise Amazon cloud. Yeah, compared to a standard laptop running the same thing. And we were like, what the fuck? What's happening there? Can't be. Yeah. And that's what this talk is about. It's about knowledge about profiling we never ever wanted to know. Yeah. It's stuff we had to figure out the hard way, and it hasn't been any fun. So, but maybe you're going to be in a similar situation one day, so it could be useful. Yeah, me, that is Johann Peter Hartmann, like everybody knows, pretty senseless to write this on the slide. I'm, as a matter of fact, a hacker turned manager, trying to find the way back, hacker at heart. Founded Mayflower together with Björn, Section 1 together with Stefan Esser. So ask me about security. I love security issues and things. And Mayflower is a cool company to prove this. This is our logo done in bacon. Yep. That's important. No, we do all the other cool stuff as well, like Nodecopter, Slack time, blah, DevOps, Lean Startup, Agile. Since 2005, we do Scrum and still try to figure out how it works properly. At least everything changes, so it seems to be something happening at least. Yeah, and we do Symfony. Every new important project is done with Symfony 2. Yeah, we're on SymfonyLive, so that happened to everybody in here. But we've been doing a lot of Zen framework. Ah, Gaylord is there. Hi. Don't tell this Zen. Yeah? Yeah, I know, you do the same, right? I think so. As a matter of fact, I've got only basic knowledge. Nevertheless, I used the Symfony content management framework as the official lab rat for everything I benchmarked inside for this talk. On the other hand side, I've got a lot of knowledge in Zen Framework 1, and that's maybe the reason why I do Symfony 2 today. And for sure, that's the reason why I know a lot about profiling today. So, profiling. Who uses the Zen profiler? Okay. Gaylord, that's something you should tell. Who uses Xdebug? Okay. I'm going to tell you some interesting points about Xdebug later. Who uses XHProf? Ah, great to see that. Who uses XHProf in production? I'm going to talk about this later. Who did some server-side profiling like Valgrind, like CallGrind, SysProf, OldProfile, and also administration profiling world? Ah, great. Any kernel hackers here? Oh, that's great. Nobody is going to know a lot more than me. Maybe you know some things better than me, but kernel hackers would be the help for me because they are much deeper into the stuff. So why do you profile stuff anyway? The reason number one is obviously, it's obvious. It's to figure out how to survive the launch, your update, your new release, or the sudden new popularity, for example, created by a TV campaign. But suddenly a lot more users are on your site. That's the reason number one. The reason number two is to figure out why you didn't survive it later. That's bad luck, because the ugly truth about profiling is really the first moment you're certain about your application's performance is one day after the launch. So you can't really know it upfront. So it's always a game of luck and mostly a game of fail or a lot more hardware than you actually would need as well. That's the reason that your pointy-haired bot thinks it's the responsibility of the software guys to make a software application that scales. Yeah, because it's complicated. It's better the software guys deal with it. And that's why the software guys think, oh, it's the operation guys. My software doesn't matter in performance because they have to scale by hardware. If my application's too slow, they've got the wrong hardware. Just buy more, better, more scalable hardware, or go Amazon EC2 Cloud. On the other hand side, the operation guy thinks that the developers don't care about performance anyway, so they blame the developers as well. So the strategy you actually use in real-day life is you make it hard to blame you. So you create an impressive presentation, providing useful information to everybody involved, and you tell them stories like, we do up to 300 requests per second, and you can prove it because you did some Apache benchmark script on the slash page or in any other cached page which is fast and you knew it. And you go out with words like this, 300 requests per second, and every request is done within 11 milliseconds or so. As a matter of fact, that's a lie, because you don't provide 300 requests per second unless somebody hacked your network, started 50 local browsers on your local network in parallel, and pressed reload 6 times a second. Because that would be the real environment where something Apache Bench created would happen. So what Apache Bench does, it benchmarks something that is never going to happen, ever. So it's no reliable information. So how do we get how do we come to reliable information? Oh, that's a typo. What everybody in fact wants to know. What are the odds that everything is up and running the day after the launch? That's the most important thing. We want to know, are we going to be stable? Is there anything we should fix before the launch? And if we already launched, is there anything we should fix then? And how do we fix it? How do we detect it? What's the reason? And how do we fix it? So first step, how to get a real test scenario. One request you create in your profiler is not the same like 1 out of 1,000 requests. A computer or server behaves completely differently if there are like 500 concurrent users on it, or just one user running an xhprof profile run or an xdebug profile run. So the first step is to create realistic load to do a realistic profiling. Realistic load is hard to do. Who does proper load testing, like with tools like JMeter? Any other load testing tool like WebLoad, Silk Performer, any other open source tool? Sorry? Oh, I don't know this one. Is it good? How many users can it simulate? 10,000. Oh, that's a good number. On one server?
Well, they have a
cloud
infrastructure firing requests.
Oh, okay. Because it's bad luck with JMeter. If your application scales, JMeter usually doesn't. So you need more JMeter servers than you need web servers to benchmark your application. Nevertheless, I love JMeter, so I use it. So that's a simple JMeter setup. What you can see here is, I haven't got a laser pointer as well. Has anybody got a laser pointer? Lucas? No, we haven't got a laser.
Laser pointer with me, but
you won't.
Yeah,
I read about it on Twitter or so. Yeah. No, on your blog or Twitter? Facebook. Okay. Yeah. On Facebook. We are Facebook friends, please. It's something completely different. And however, that's a typical JMeter setup. Because what you see here is 3 thread groups. That's an interested visitor and visitor looking. Thank you. Great. Okay. I could just point into the audience, have some fun. That's the first thread group, interested visitors. There are 20 visitors visiting the site at the very same moment. We take 10 seconds to fire everything up. There's another visitor group looking for certain information, and there's organic Google traffic that actually didn't want to visit your page, and so it just bounced it back. So you create a proper test setup, and if you did that, you have to check if your setup you're going to provide, or the load you're going to provide, is realistic. That's easy if you're already online, because you know what kind of traffic you have if you're already online. So to make a proper JMeter testing environment, you simply have a look at your web analytics tool like Webalizer, Google Analytics, AW, stats, analog, and so on. And if your JMeter test generates exactly the same fingerprint of load, so it looks the same in your web analytics tool, you're fine. Yeah. We went one step further. We did some statistics based on the log files by the load generated by the JMeter test, or by the production access log files. And we created a fingerprint of all production access log data, so how many URL, or what kind of URLs have been called, how often, and so on. And we did the same for the JMeter test, and we did a correlation for both lists. And so we were able to say, yeah, we are going to be as close as 99.5% to the real environment by the test environment we created. So that's a good thing, because you can tell your boss or your customer, when we launch or when we introduce a new version, we know for sure, or for 99% sure, that we are going to be able to survive it. It's more complicated if you haven't launched yet, because you have to create something that is close to a reality you don't know yet. So what you can do is you create scenarios based on personas, or in performance testing they call it virtual users as well. And that's the thread groups I showed you some slides before. And you do two setups. One is the first worst case setup, users doing all the expensive stuff. And the second scenario you create is users behaving normal, what you really expect them to do. You implement JMeter test for that, and let's just start them. And on the other hand side, you implement some monitoring on your servers. A quite common tool is cacti, especially in the PHP world. Who's using cacti right now on his servers? Who's using Munin? Munin is more fun than cacti, right? I think so. Or you can use, if you haven't got Munin or cacti installed anyway, you can use JMeter perfmon. JMeter perfmon is a plugin for JMeter that takes all the server load statistics and provides them in JMeter as well. That's what you're going to see if you've got a Munin. That's the real Mayflower Munin server. And for example, we've got too much CPU here. Everything yellow is idle, so we bought too much CPUs for the server. It could do some other things, just to see what's happening when your JMeter tests are running. And if you're using perfmon, you see pretty much the same information just inside JMeter when your tests are running. So it's a good thing. So if your JMeter tests are running, the things you have to look at is, of course, every resource usage on your server or on your server cluster. That means the user load, the system load, the I/O weight, that's the part of the load. Everybody probably knows top, right? The command line utility from Linux. Yeah. Would be bad if you don't know it. I/O wait is the time you're waiting for I/O, like hard disk, network, and so on. Interrupts is number of interrupts calling the kernel or the CPU. It's not that important. Sometimes when a controller board is broken or a network device is out of order, it's important and leads to weird bugs, but most of the time it's not important. Context switches starts to be more important when you get to bigger installation, and forks as well, because they're just expensive, kernel forks. You have a look at the memory usage, and of course the most important thing is the free memory. Is there still some memory left? Are we going to use some swap space at all? And page faults. Page faults is not the same as using swap or not. I'm going to explain this later. And of course network in two variants. That means how much traffic is there? Have we got a lot of network collisions there? A lot of packet collisions there? Is everything's fine? This is important. You would think that in the age of gigabit network cards, network isn't an issue at all anymore. But I've seen web clusters completely saturated, or traffic-wise completely saturated by memcache traffic. So if you do a lot of caching, there's a lot of traffic resulting from memcache. So it starts to be important again. And of course, hard disk performance and SSD importance as well. And of course, you need a lot of consoles. If you've got system administration guys involved, you'll see like 32 consoles on one laptop opened up, thanks to the bigger laptop solutions we've got. Inside the consoles, stuff like top. I think everybody knows it. I/O top. I/O top is a bit more interesting. Who doesn't know I/O top yet? Okay. I/O top is great. It's a small Python script, and it's telling you the I/O generated by a certain process. So if you got an I/O issue on your server, you see in your top statistics, you can figure out who's to blame. So I/O top is a great tool. VMstat, another default Linux command line tool, originally a virtual memory statistic tool. That's why the name is VMstat. It cares about memory, like paging and memory usage, swap space, and so on. But in the meantime, it cares about processes or device usage, partition usage. So if you want to figure out if there is a slow hard disk resulting in slow performance, VMstat is a tool to have a look at. And this prof is great. I'm going to tell you more about this later. Yeah, you've got your monitoring infrastructure up and running, and you've got your JMeter tests up and running, so run all the tests. For Symfony you don't need any ramp up because everything's already cached and warm due to app console. No, of course you have to do ramp up because the data has to be memcache and so on. So you have a look at what's happening when your JMeter tests run, and if you're lucky, everything works, so the application is stable, the system is stable, the load stays at one level and doesn't increase, there's no certain resource that is used more and more and more, or even worse, you got this hockey stick line in your load testing that in that case it's completely screwed later, and you've got a good service quality. Good service quality means that the site is still responsive. Everybody got every request through, and everybody can do whatever transactions they want to do. So it's great. We have a setup for realistic profiling due to a fine JMeter test and a fine monitoring infrastructure. If you've got a negative outcome and it's not stable anymore, it's good luck as well, because now we have a need for realistic profiling and we've got the setup already done. By default, if you do profiling, we do it inside our IDE, because it's already there. Who is using PHP Storm? Yes, it's the most popular IDE. Let's do the hipster check. Who's using Sublime 2? Let's do the old school hipster check. Who's back using VI? I don't dare to ask, but I'm going to ask anyway. Who's using Emacs like me? Okay, thank you, brother. Yeah. Well, but it's coming back. If VI is already, came back, Emacs is coming back as well. But who's using debugger inside his IDE when he's doing software development? Okay, everybody should do that anyway. Who's using the profiler option of the debugger you're using? Okay, so we should tell the IDE companies that profiling in the IDE isn't actually needed because nobody does it. The bad thing is it's different, because if I do this JMeter test and I do a single request on the Symfony content management framework, I end up with a responsivity of 200 milliseconds for this request. That's not bad. APC caching wasn't enabled at that time, so it was quite a fine result. If I do the same request with Xdebug installed and with Xdebug logging activated, I end up with 1.5 seconds. So quite slow. We thought, oh no, that can't happen. It can't be that slow. So we did some more benchmarking, and we saw that Xdebug actually is up to 12 times slower than the normal request. So just to enable profiling makes your request a lot slower. And you could say, no, that's fine, because everything's slower. Yeah, it's just relative. You just have to divide everything by 12, and it's fine again. But that's a lie, because relative speed isn't the same like wall clock or real speed. Because a 20 millisecond database query and a 100 millisecond request is 20% of all time used. And the same query in a 1,200 millisecond request is just 1.6%. So you don't get the information what's really happening in your production, what really matters in your production environment, because it's screwed by the performance impact your profiler brings. So your profiler lies. It gave you the blue pill. So what does really happen in your application? That's what your profiler tells you. Who ever used the Xdebug call grind features, the call grind format export? Okay. It's a nice one because you can do a lot of analysis using tools like kcachegrind. And it's going to tell you, in that very case, that the autoloader is very, very, very slow. Okay, that's not a big surprise in the Symfony world that the autoloader is a slow thing. But it's a proof that it's very, very slow. So you see, okay, most of the time is spent inside the autoloader in my whole request. So everything else seems to be fast, and the autoloader is something you can solve. We already know how to do it. But that's not the reality, what Xdebug is telling you besides the speed impact, because Xdebug tells about a wall clock time. That means it tells you what time was spent when, but it doesn't tell you how the time was spent. You know this certain method call took 1 second, but you don't know what it did in this second. Because you don't know the time spent on CPU, you don't know the time spent on I/O load, you don't know the time spent by other processes. You just know that it took this long. So we have to have a look one level deeper, since obviously the Xdebug call grind file wasn't a spoon at all. So one level deeper, that means user process level. To analyze this, you can install sorry, my language unit's broken right now. You can install Valgrind and all needed debugging symbols. The debugging symbols is something you get by your Linux distribution, and especially if you're using Ubuntu as a platform. Who uses Ubuntu as a default platform? Okay, maybe I should ask another question. Who doesn't use Linux for development? For the development server infrastructure. It's okay to use a MacBook. It's not okay to use Windows, but it's okay to use a MacBook. Yes, it's, as a matter of fact. There's no Windows laptops anymore in Mayflower, and we are proud of it. Pierre's not here yet, right? Yeah, you can install any, or what you have to do to have proper profiling on a process scope. Install Valgrind, install all debugging symbols you can get hold of, start the JMeter test, and run a single Apache child in a separate process. Start it inside Valgrind and using callgrind as a tool. So that's the command line you can copy and paste from the slides when they are online. And what you get is what really happens inside your application on the process level scope. And the process level scope tells you, oh, that's completely different, because most of the time is spent inside Zend parse and leg scan. So that means it's spent inside the Zend engine itself. So not my PHP script had the biggest impact, but the biggest impact was created by the Zend compiler, or by the Zend engine's compiler and scanner and parser and so on. So there's another reason why my application was slow, and it's not the same reason I could see in Xdebug. To fix this, we can use APC again. But again, this is not the whole truth about the application, because it's just one process. And even Valgrind is telling you just a part of it, and it has a big impact on the performance of this process as well, just like Xdebug has. So we have to go one level deeper, and this level deeper is sysprof. Sysprof is a Linux command line utility that is profiling the entire system. So it's profiling user space and kernel space, and that's the great thing about it. It's a fast profiler with a low fingerprint. It doesn't screw everything, and that's good, because you get rather realistic information. And it works on some kernel services provided since kernel 2.6 or so it's available pretty much everywhere. To start sysprof, you have to install it first. It's good if you've got all the debugging symbols installed to be able to read what's coming out again. And you just start the command line utility, sysprof CLI, my out file. You let it run as long as you want to, and then you press Control-C, and it stops and it writes an out file on the hard disk. So everything's inside memory, but that's most of the time fine. And you just write it into an out file, and you can start the official or the real graphical user interface of sysprof with sysprof my out file, and that's what you're going to see. That's what happened on the whole system. And in that case, I benchmarked the Symfony content management framework, and I used Xdebug installed, but not activated. So the xdebug.so was loaded, but it wasn't an action. There was no profile run, there was no debug run, there wasn't anything. It was just started. And when you have a look at what's happening inside the PHP call is that most of the time is spent inside PHP, and that's good, and that's fine. But 20% of the time is spent inside getTimeOfDay. GetTimeOfDay is a kernel function, and it's a kernel function telling you what time is it. That's the wall clock kernel function. And it's a slow kernel function, since the CPU has to talk with the built-in clock. And it's especially slow if you're in old Linux environments, and it's even more slow if you're in old 32-bit Linux environments. So that's something you see quite often in real environments if you do an strace on a PHP process or an Apache process with the PHP module, that you see a lot of calls to getTimeOfDay when Xdebug is activated. So in reality, we spend 20% of the whole CPU time of the server asking the kernel for the current time, because Xdebug is installed. So that's the reason why you shouldn't install Xdebug in production systems at all. Or you have to buy 20% more CPU to deliver the time of the day to the Xdebug process. Yeah, that's the Java, that's Jackrabbit. By the way, Lucas, in my benchmark, Jackrabbit and the PHP CR provider based on Doctrine DBEL was the same speed. Did you do some benchmarking?
Well, no.
Okay.
We did some benchmarking, but not really to compare it within that scope.
Yeah.
I can assure you that Jackrabbit will scale better.
Yeah, I only had a small data set, for sure. I expect the same, and I was surprised because I expected it to be a lot slower, not using Jackrabbit. But it wasn't that slow. That was off topic, sorry, but interesting. So if you got Xdebug installed, everything is going to be slow. So that's what really happened in your whole system environment. You can get a similar information using the system utility perf. Perf is default provided by Linux for like 2 years now, and it's based on the perf event kernel module, so it's available pretty much everywhere. Just like this prof, it's a fast profiler with a low fingerprint. It works similar, and it probes with a certain set of probes. So what it does, basically, in that case, I just call the command line command perf record everything 10,000 times a second and for 60 seconds. So that's what's happening here. So the perf utility sends 10,000 events in 1 second and just has a look what's happening inside the kernel right now. And if you have a look at perf report, later by the data created in the time, it's written into a file named perf data. Perf report displays you what actually happens. And what you see here is that the calls the time has been spent in, or the calls that has been active in the very same moment the probe in here was running, was happened in ZenM memory management alloc. So in that very case, the reason for delay was the access of memory. So your application gets slower if you use more memory, because the memory bus is a lot slower than the CPU itself. That's another way. You could go for this prof as well. So with this kind of utilities, that's how we tried and finally succeeded to survive our war stories. War story number 1. Number 2, actually. The slow cluster and the fast Lenovo. Yeah. The obvious solution would be the migration of the whole cluster environment to a laptop. Yeah. Give it a fast internet connection, plug it in, and you're done. Everything's fine. Yeah. And you could scale it by adding more Lenovos. Yeah. For some reason, our customer wasn't this fond of this idea. I thought it was great because we still have a lot of Lenovos in our office. So he won't go with it. And of course, we did some normal profiling. So we did Xdebug profiling, we did hprof profiling, we did IO-top, VMstat, and everything was fine. Yeah. So we could prove to our customer, no, everything's fine. We did some profiling, and well, the site is slow, but for no reason. Yeah. Bad luck. Customer wasn't happy with this Acer, so we had to have a deeper look. And that's what we did. We did this perf, and what we saw is very interesting because the reason was page fault. Page fault is a Linux kernel function that is usually being called when a page in memory, we're talking about memory pages here, is not available because it's swapped, it's somewhere in the file system by default. However, if you're in a virtual environment, it could be that there's some shared memory extension inside Xen, the Linux virtualization solution, is installed. And in that case, the shared memory pages are marked as read-only memory pages first, and they've got a different state inside the memory management unit. So every time you accessed a certain memory page that was shared over other virtual machines, you had a page fault. And this was slow, because you had to make a copy of this memory page. So every time we accessed a certain byte inside the memory, there was a complete copy of the shared memory page being made, and that slowed down the whole system. So the reason was some issue inside the Xen virtualization used by Amazon. And the solution was rather simple, because that's a bug that only exists inside 30-bit guest OSs with a virtualization running in 64-bit. And it's been fixed since August or so. And so a solution would be just to move to another zone where you have less memory sharing, because the other instances on the same host have a completely different setup. Or you just switch to a 64-bit guest system. So the reason in that case wasn't the PHP, it wasn't the processes, it was the virtualization itself, one level deeper. Was story number one, the video on demand platform, where everything was fine until 10 minutes before the live event, and then everything was stuck. Of course we did the same, like, oh, well, it's Xdebug profiling, XHProf profiling, IOTop, VMstat, KAKI monitoring, everything. And everything was fine again, just stuck. Didn't work anymore. So we tried to do a lot of benchmarking and to do a lot of JMeter tests and so on, and we created virtual users and everything, and we couldn't get hold of the issue. So what can you do? It's very easy. The only thing left to do is you wait for trouble. You wait for the next live event to get screwed. And that's what we did. Of course, we opened up like 50 terminals running any top, like ATOP, top itself, HTOP, IOTop, MyTop. Everything top was started. And when the 10 magic minutes came, when everything got stuck, we saw something similar inside MyTop. That's MyTop, and I know it's too small for the people in the back of the room, but I'm going to read it. MyTop is like a top, but just for MySQL process. That means for MySQL select statement, insert statements, for everything that's happening here. And what we saw is that we had a lot of processes in a locked state, like you can see it here. All of them were locked. And that was a surprise, because it never was locked before. It always worked out. Even with a simulated user environment we did, it wasn't locked at all. So we were thinking about, why does it suddenly lock the whole system up? And thanks to the help of the MySQL proxy and some small scripts, it's a more modern version. Back then we used a different version. You can see what statements are fired against the MySQL server, or the MySQL server's cluster, without any, or with only a small performance impact. So what we did is we set up a separate server with the MySQL proxy, redirecting every traffic to the actual server, and we changed our application to use this proxy instead of the real server. And this server generated an out file where every MySQL statement fired against the servers was logged, including the time it took in microseconds. And we did this for the 10 seconds, or for the 10 magic minutes when everything got screwed. And what we saw was pretty easy in that case, Because when you had 500 registering users, that means 500 users being inserted into the user table, and 1,000 logging in users, that means 1,000 users reading from the user table at the very same time. In the same minute, you've got a table lookup. So what happened is the table was in a constant log state, and that's why everything was stuck. And yes, the solution was simple. Just a migration from MyISOM to InnoDB was back in the old days when you still were using MyISOM. And it was the default of the enterprise shopping platform, so that's why we used MyISOM. And it's been like 5 or 6 years ago, quite a long time. So that was the reason. And the solution was simple in the end.
So the problem was you weren't using an enterprise database with your enterprise e-commerce.
No, we have been using an enterprise database for the enterprise e-commerce, but we did it wrong. In that case, yeah. Yeah, surprise, surprise. It looks very, very stupid if you have a look at it now. Yeah. It was different back then. That was a time when you still had discussions about object orientation in PHP. Yeah, we have different other war stories. We had one set up with the IBM kernel module screwing I/O in concurrency, hiding every useful information. So it was an IBM hack for the Linux kernel that actually screwed the whole platform. If anybody's interested, I can tell you later in a personal meeting. And we had some issue with in-memory caching layers that screwed more of the caching than it actually helped to improve performance and so on. So there's a lot of things. And all of those stories have been solved by Linux command line tools like sysprof, perf, oprofile, which isn't that modern anymore, and valgrind and so on. So it's useful to have this knowledge to solve real production systems. So probably like 80% of you are thinking, why should I care? I'm a software developer. Yeah? I'm not a system administrator. It's not my problem. Just like I told you in the beginning. Yeah? If the performance is bad, it's the system operators. It's not me. No, as a matter of fact, most of the time, nowadays, software developers define the systems. They create the architecture. That's why Puppet and such things are popular right now. Because your default PHP application isn't anymore an Apache and MySQL and a PHP. It's an Apache and MySQL and PHP and a MongoDB and a Memcache and a light HTTP or Nginx. It's a varnish, so it's a bigger setup, and the setup hasn't been created by the system operation guys. It's been created by the software developers. So it's your infrastructure that's out there running and getting screwed. DevOps, that's a trend resulting on because of this. You are responsible for production too, just like the system operation guys are responsible for your application as well. So DevOps says you have to care about the other issue to be able to solve problems. And as a matter of fact, that's what the experience says. If you've got a bug inside operations, neither the system administrator nor the software developer is able to fix the bug on its own. Or you always need to cooperate to get it up and running. So, besides that issues, what's in for you? A recommended setup. That's happened by accident, and it's not very surprising. My benchmark test, Symfony Content Management Framework, 1,400 requests with a concurrency of 20, so a pretty average setup for a content management server. And some benchmarking being done. Pure PHP is slow. Surprise, surprise. With APC, it's faster. Not so surprising as well. With Xdebug in APC or with Xdebug, that's without APC, it's slow. So if Xdebug is installed, it's slow anyway. So don't install Xdebug. On the other hand side, if you install xhprof, it doesn't really matter. It's the same like a pure PHP installation with APC. Oh, that looks wrong here. That shouldn't be that way. And something interesting, does anybody know New Relic? Okay, I love it actually, until some days ago, because New Relic has a major performance impact. if you got New Relic installed and activated, it slows down your performance by 30%. I was surprised by that, but that's what I did this benchmark for some time, and it really slows everything down. Okay, and what you should remember for this talk, if you're profiling, take the red pill, try to figure out what is really happening, try to get out of the software development matrix. Yeah. And the tools that are going to help you are tools like sysprof, perf, volgrind, callgrind, mytop, MySQL proxy, xdebug, and so on. So in the modern times, when DevOps and when operations is a topic of software development itself, that's knowledge we have to provide. So, and I've got officially like 5 seconds to go. I started later, so now I'm done. Thank you. Any questions you want to ask now? Yes?
Wait, I have the microphone.
I would like to see some shouting.
Can you tell me more about New Relic? What does it do? What do New Relic?
New Relic is a tool that provides in-application monitoring. So it's a module you install on the server side, and it's talking with some cloud solution. And you get every statistic from inside your application on this cloud solution. So PHP performance, MySQL performance, OS performance load, and so on. It's a nice tool, actually. It just it reports about performance that is like 30% slower because it's installed. And that's bad. Yeah.
What about end-user performance? These days we have a lot of JavaScript-rich client front ends, and this is a cause of bottlenecks as well, I think.
Yeah, for sure. I haven't talked about it. Ilya has a very, very good talk about everything's happening, so layers up from what I've been talking about. And the slides are online.
Okay.
But, no, Ilya. Yeah, right. But, yeah, you're completely right. Most of the time it's more important for the user that his experience is slow and not the server side is slow. Yeah.
Have you tried Varnish Replay to generate load on your servers? We tried different solutions, especially recorded load. Yeah. The problem is that you're less flexible. So especially when you've got new platforms, you can't give certain configurations a try. So if you just want to assure that the system is going to stay stable, that's the perfect solution. Yeah, but I haven't tried it yet because I haven't had the need to for exactly that case. Most of the time we have the need to assure that some changes are able to be survived as well.
Cool. Any other questions? Okay. Thank you, Johann.
Thanks, everybody.